Section 3. Make it truly alive. Welcome to the next section of our hands-on AR course. In the previous section, we developed the presence of our virtual assistant, who can move across the planes and stream an audio file from the web. We guided our assistant's attention towards the camera and simulated its jaw movement to establish direct connection with the user. In this section, we will further develop our assistant to behave more realistically and respond organically. We will start with introducing awareness of AR Foundation's concept of plane alignment. Next, we will proceed to developing more functionalities such as visual and audio effects, a playlist, and voice control. Video 1. Understanding plane alignment. In the app we created in the previous section, you might have noticed that our assistant can move from the floor onto a wall if Plane Manager detects a vertical plane. Another thing you could have encountered is that when you tap the screen multiple times, one after the other, the assistant gets confused. The assistant behaves similarly in the editor. It's a simple issue to fix in case you haven't already. Let's patch the bug that makes our assistant misbehave if we touch or click before it reaches its destination. We are in the project from the previous section. In the meantime, we have updated our Unity. The wonderful thing about AR Foundation is that it is native and it is easy to update, even though the experimental part of API can be still largely overhauled. Now to the spawn and guide script. In the update function, please go to the if statements for mouse and touch input respectively and add and is not moving to the event system clauses. There is one more thing we need to tweak for the editor just to make sure everything works smoothly. Just as we added input get touch phase equals touch phase began to the touch input if statement, we need to turn get mouse button into get mouse button down to avoid mouse clicks being counted every frame the button is held. Now the statement can be triggered again only if the user releases the button first. Now we can test and we see the bug is gone. Now we are ready to delve deeper into the Unity's AR systems. At the beginning of the previous section, we mentioned AR subsystems that manage AR session. The manager inherits from system object, which requires using system declaration for some calls. We see the list of available subsystems and we could subscribe to plane subsystem in order to determine the plane alignment. Please feel invited to inspect available methods and events in detail, such as starting and stopping subsystems and effectively the session. We will scroll down. What we might be interested in is the plane added or perhaps plane updated, because we would like to know what kind of plane we are looking at. Is it horizontal or is it vertical? Plane alignment is a useful functionality in AR Foundation, which we would like to utilize in this section. Both plane added and plane updated are helpful but not necessarily suitable for reporting on which plane we are using. As the names suggest, these functions are called only if a new plane has been added or one of the existing ones updated. We could subscribe to AR Subsystem Manager or XR Plane Subsystem, but our already existing AR Plane Manager component on AR Session Origin has a subscription to plane alignment via raycast, so we can take a shortcut. We can call a method for AR Plane Manager when we raycast around the space with the camera by simply looking around. We will call try-get-plane method, for which we will need the trackable ID of the plane we are looking at. Let's create a new script to understand exactly what is necessary to distinguish planes. In the next video, we will implement this functionality into our spawn and guide script, since the app's behavior is intimately linked with our virtual assistant. We will use experimental XR and AR Foundation namespaces, as well as UI for feedback. Let's declare AR Session Origin and AR Plane Manager. We will also need the center of the screen as a reference point for our raycasting, both on the target device as well as in the editor. Let's initiate Session Origin, Plane Manager, and Center in the awake function. Center is simply width and height of the screen divided by 2. We will also need a list of our AR raycast hits and the UI debug feedback field. Let's declare them. Now in the update function, we declare our ray similarly to our spawn and guide script, but instead of mouse position, we pass our vector3 variable called center. Next, we issue session origin raycast if statement, passing ray, plane hits, and trackable type plane within bounds, because we are interested in a bounded plane. Now let's create a new variable which will extract alignment from bounded plane enumerator via plane manager. We call the earlier mentioned try-get-plane method passing the current plane hits trackable ID. Now we can simply output the result to our UI. Let's save the script and check if our approach works. We need to add our script to AR session origin object, then assign a UI field. Since this UI is temporary and independent from our assistant, let's duplicate our canvas and create a new UI text and align it to the top middle of the screen. Assign a font, preview, should be alright for testing. Now populate our gaze plane script and build. It works great. We can immediately see the feedback. Okay, now, how do we test in editor? We look forward to Unity introducing testing in the editor that does not require running ADB. AR Foundation Preview is still in alpha, so let's simulate testing in the editor to go ahead with it now. Create two planes that will be our points of reference, horizontal and vertical respectively, and assign them respective tags. Let's keep them small and place them relatively close to us, so our assistant can interact with the planes in the following video. Now we can reopen our gaze plane script and add the isEditor if statement. We preserve our screen point array on the top of the update function because it will be equally useful for all, both AR Foundation and the editor mode. We need to declare our raycast hit and use physics raycast to determine if ray actually hits something on its way. We can use debug drawLine to see our ray in the scene mode. Now let's compare the tags of colliders we will hit with our ray, and depending whether it is vertical or horizontal, we will pass it to the UI text. Alright, we can now test in the editor. We see the debug line as well as correctly printed names of the planes. Before building the app, we can disable the planes through script or inspector hierarchy, which I will do now by adding it to an empty game object, editor only. In this video, we found out more about AR Foundation systems and found out a few ways to determine the alignment of a plane using camera ray method, which is the most straightforward and reliable for many AR apps.